and lots of issues to address. So here's the agenda for today. I want to talk about what is agentic AI, right? So what is an AI agent? What's in it? And then talk about some ways in which it communicates, right? So various protocols that it uses. I'm not going to get into like super technical detail. This is meant to be more an executive level briefing. But the reason I'm covering it is when you think about the cybersecurity of some kind of an entity, you need to know what it's made up of and what it talks to and how it talks to the things that it talks to, right? So that's why I want to delve into this into a little bit of detail. Then I want to talk about what are the various kinds of agentic AI deployment models that companies are using these days, and then what it means in terms of your attack surface and cybersecurity risk. Now, this is not a problem just for yourself. It's also a problem for me because everybody's adopting agentic AI, right? And the whole world is doing it, which means that the frameworks and guidelines process has also started. And there's a whole bunch of those right now, and they're evolving, and I'll cover a whole bunch of it and how to think about it. And then talk about defensive strategies and also provide you with some tools, and then finally some resources that you can actually use and then measure yourselves over time. So far, so good. Okay. So what is agentic AI, right? So let's jump into it, right? So you have AI. So if you go to ChatGPT or you go to Claude or you go to Google Gemini, you have what's like a query window. You're in your browser. You can just ask it a question and it answers, right? Or you could interact with an AI on like a chatbot of a website. So that's AI, right? Agentic AI means here's a use case which differentiates. So think about an automated AI that sits inside your infrastructure or maybe on a cloud, but wherever it sits, but it works autonomously. So think about something that can autonomously load balance your network, right? And also find problems and then auto correct it, right? So it's got one job, but it can completely accomplish that in a rinse and repeat cycle, right? So that's the differentiation between the two. But let's put that into more of a detailed view, right? So an AI agent fundamentally can do autonomous decisions, meaning that there's no human needed in the loop, right? It can reason. So you give it a job, it can figure out the constituent parts and it can reason and come out with a plan to get to that goal, right? All on its own. It doesn't need you at all. Third, it can figure out if to do the job, it needs to access tools. And then it can figure out what tools it needs to access and how to access those tools as well, right? And last but not the least, if it needs to communicate with other agents, it figures that out as well. So all of this happens completely and totally autonomously within an AI agent, which is very, very, very different if you think about your interactions with ChatGPT, Gemini, etc. So let's think about that in terms of the 5 areas, right? So let's think about it from the standpoint of decision making, the scope of its actions, tool access, risk profile, and the extent of human oversight. And let's compare and contrast with traditional AI versus agentic AI. So in traditional AI, you give it a prompt, it responds to a prompt, right? Very simple. That's a decision. Next, it's single turn. So you give it a prompt, it responds to the prompt, then you have to give it another prompt, and then it responds to that. So it's single turn action. It's not multi-turn by definition. Third is, in terms of tool access, it's unless you upload a file or you somehow connect it to some kind of a database or some kind of a resource, it's not going to automatically go find a tool or access any tools, right? It's limited or it doesn't at all access any tools. It just uses its existing knowledge for the most part. In terms of risk profile, that's good, right? Which means that the risk is limited to the query that you're using, right? And then it's on a query by query basis. So that's why I say it's bounded. And it's predictable, meaning that you know what kind of a response you can get and you can go verify it, right? And it's not accessing external tools unless you manually connect something to it. And then last but not the least, is human oversight is on every interaction, right? Because it's a single turn, like I said, you get to oversee the answer before you use that answer in any fashion. Now, contrast this to agentic AI. Agentic AI acts autonomously towards the goals, right? So you just give it a job. Go book me tickets or manage my calendar and my email. That's it. It's a generic job. and it figures out what it needs to do that. It can do multi-step, right? So it can come back and say, hey, to do this job, I need to get some clarity from you. And it can ask you for more information, or it can go query other agents. So it has this multi-step process within it. And third is it can access other things, right? Maybe APIs, maybe databases, maybe your browser, maybe another application inside your company, right? Whatever it needs to access, it'll look to access and get the job done. And then the risk as a result is, this is what we talk about in cybersecurity as a blast radius, right? So the blast radius gets more expansive and it's harder to predict. And we'll walk through why that is in some of the use cases. And then in terms of human interaction, you give it a job and it just goes and gets it done, right? So unless you set up a process where you make it check in periodically on its intermediate steps or outcomes, there is no human interaction. It's almost completely autonomous, which again means that the risk profile is very different to standard AI. So let's see what's inside an AI agent, right? When people say there's an AI agent, what the heck is it, right? So there's really 5 parts to it. One is its identity and the scope of the agent, right? So for every AI agent, there's something called an AI agent card. And I'll walk through that in a follow-on slide. So it basically says what this agent is and what are its capabilities, right? Second is an AI agent has memory, right? And it has 2 types of memory. A short-term memory, meaning that I'm interacting with the agent right now. So it has to remember what all I'm saying to it. So maybe I'm trying to book airline tickets, but I say, oh, wait, hold on. I needed to book a ticket, make sure that the flights are never before 10 a.m., right? I can't get into Boston that early in the morning through the traffic. So book flights only after 10 a.m. And then, oh, make sure that only nonstop flights are booked, right? So it has to understand all of these requirements that I put into the conversation in the current conversation. But also it has a long-term memory because AI agents also learn from their previous interactions, right? So maybe you booked a ticket and Mr. Nybakin comes in and books another ticket. Now, between the two of you, the agent has now learned something from your booking, and then it's correcting itself for the second booking, right? Or maybe it's learning from the history of all bookings and finding knows where to find better deals because it's stored all this information in like a database from prior interactions, and its learning model is learning to update itself based on that. This is something that's called RAG. You might hear the phrase RAG. It's basically retrieval augmented generation, where it's learning from its past experiences based on inputs that are available from those experiences. Then it has a tools layer. So remember, I told you the AI can figure out what it can, what tools it needs to do to get the job done, right? So it goes and figures out what are the tools I need and how do I access it, right? So it's through APIs. So maybe it'll go do a web search. Maybe it has to go access a GitHub code repository. Maybe it has to interact with your finance application. Maybe it has to interact with a whole bunch of other AI agents, right? But it figures it out, and then it has the connectors in order to go interact with all of those tools. And then what is critical is what's called the planning and control loop. This is what is the core logic of the AI agent, right? And I wrote react, and that's not a typo that over there. It's react as in the reason plus act. That's the logic loop it uses, right? So it goes through a thought process. It thinks about the job, breaks it down into tasks, and it says, what should I do next? And then for that task, it decides, hey, do I need a tool for this? And how do I use that tool? And what do I get back from the tool? Then it observes what it gets in response from the tool or intermediate steps. And then it repeats that cycle over and over again until it finally gets the job done. And then last but not the least is the core of it. It's the brain, right? This is your large language model. So behind these AI agents, there's always a large language model that it's relying on. This could be OpenAI, it could be Gemini, it could be Claude, it could be Grok, whatever it is. But there is a AI model in there, and is responsible for 2 things: helping in the planning process, but also self-reflection, right? Meaning that once it gets the job done, it reflects on it and tries to understand, has it made errors, and does it need to correct itself before moving forward for the next time around? So that's what constitutes an AI agent, right? There's these 5 parts, and it's critical to understand this because now that you know what it is, think of it from the attacker's perspective. So if I want to attack an AI agent, I could attack this along any of these 5 layers, right? So keep that in the back of your mind as we progress through the remainder of this presentation. Now, second is it needs to talk. So how does it talk? So there are essentially 3 protocols, and it's actually going to be 2 protocols, and I explain why. So there's model control protocol, which is basically an open standard that Anthropic released. And modern control protocol helps an AI agent talk to external sources. Think of it like a USB connector for AI agents. So this is what it uses to connect to, say, your database or a file repository, or maybe Slack, or maybe a web browser, whatever other tool, right? It's basically a protocol that allows it to communicate with external entities, right? The risk is, like I said, you have to think like an attacker. Now, if you know that an agent is communicating to external sources, it expands for the attacker the scope of what the agent can access. But also, if the agent goes rogue, it expands the risk profile of it, right? So that's what comes with the use of a model context protocol. Next, there are 2 protocols that are similar in that these are used exclusively for agent to agent communication. So one AI agent has to talk to another. They use either agent to agent, which is A2A, or agent control protocol. A2A is Google's protocol, and ACP is IBM's protocol. Now, here's the good news. We don't have to learn both. We only have to learn one because ACP has been donated by IBM into the Linux Foundation and is now being merged into A2A, right? So at least for the immediate future, as far as I know, we all now only need to learn A2A, right? And there is now a migration path for all those people who have deployed ACP. There's a clear migration path as well to transition them over to A2A, right? So for all practical purposes, we only need to keep in mind 2 protocols: model control protocol, which is agent to external sources, and A2A, which is agent to agent. So with that, let's look at what's inside the model control protocol, right? So model control protocol, like I said, it connects to external sources. But what's key to understand is that it is bidirectional, right? So it doesn't just ingest data, it could also potentially write data, right? So you need, whoever is giving you your model context protocol server, your MCP server, you need to be super careful about that source of that server. And I'll walk through some examples of that as well, right? So it's bidirectional flow, which means that the agent can write back into your database as well as absorb information from it. So what is the problem that a model control protocol, model context protocol solves, right? So first of all, the world was like this, right? You had an LLM like Gemini, whatever, and then you had tools like Slack, Google Drive, GitHub, your database, all connecting to like with unique APIs. So if you change your LLM, you went from Claude to Gemini. Now you need another set of unique APIs. So this is essentially a management nightmare, right? So model control protocol comes in between, right? And it basically provides a seamless way for anything to connect to external sources and interact with the LLMs, right? So it kind of unifies that problem. So now let's look at A2A protocol, right? Agent to agent protocols. So first of all, there's your client agent. So client agent is you. It could be you trying to interact with your AI, with an AI agent for a specific purpose from using your own AI agent. It could be you trying to interact from an app. It could be you trying to interact with that agent through a web browser, right? So for all practical purposes, that's your client agent. And then it's what you interact with. So this is your A2A server, which is your remote agent, right? So you're going to make a booking and you're going to interact with a booking agent on the other side. Now, there are multiple parts to this whole interaction. So first thing is agent card, like I said. So the agent card identifies the agent, its capabilities, and its authentication mechanism. So the developer of that remote agent or the A2A server is the person who defines this agent card, right? So they could set up OAuth-based authentication, or they could say authentication is through an API key that you should have, right? Or they may even say it doesn't require any authentication. This agent is open, right? So think about all of the scenarios that which get exposed by the agents that you're interacting with. Second is what's called a task. A task is a unit of work, right, needed to accomplish a request, right? And every task has a unique ID and a progress state, right? So the state could be submitted, working, input required, completed, failed, right? It's one of these 5 states. So if you have a request that just takes one task, it's very simple. But you may have a request that may take several tasks, in which case, and some of them may run in parallel, in which case the AI agent has to keep track of the status of each of these and maybe even provide intermediary inputs back to the requester agent saying, yep, I got 2 out of your 3 things done. I'm still waiting on the other one, right? So it's for that kind of like status updates, etc. Then there's messages. Messages is essentially, it could be your answer, the final answer. It could be a context, meaning that the current chat that you're in with that agent. It could be prompts, it could be questions, it could be status messages, it could be replies, right? But these are essentially, all of these fall under the category of messages. Then we have what I call artifacts. Artifacts is your final output, right? So you've given this agent a job, it comes back and said, job done, here's the output, right? That is your artifact, right? And this could be a document, it could be an image, it could be a spreadsheet, or anything else, or a reservation confirmation email, whatever it is, right? But that's the final output. And then last but not the least is a very critical piece called the part, right? A part is essentially a piece of content within a message or an artifact, right? So your message, you could have an intermediary message where it's coming back and saying, hey, I did this and I found this intermediary file. Is this looking like what you want, or should I make more adjustments, right? So that file is a part, right? So you can have a text part, you can have a file part, you can have a data part, but it's an intermediate, it's a piece of content inside either a message or an artifact, right? So again, keep the criminal's mindset on and think about, when I want to attack an AI agent, where do I attack it? You have all of these constituent parts inside it and inside the communication channels as well, right? Okay, so how does the actual protocol work, right? So the protocol works this way, right? First, there's discovery. So you want to book a plane ticket, your agent goes and says, hey, who all can help me book plane tickets? And a bunch of agents say, yep, I can do that, and here's my agent card, right? So first of all, there's an agent that has to go in and decide out of all these agents, which ones are best suited, what's out there, and what's best suited, right? So once a decision is made to pick and have communication between a couple of agents, the next step is authentication. And like I said, it's whatever the designer of the server agent says is the authentication mechanism. API key, maybe it's OAuth, you're logging into your Facebook account, your Google account, whatever it is, or maybe your airline miles account, whatever it is, you're authenticating. And then the remote agent provides you with authorization on what it is that you can do with that agent, right? So here are the 4 things that you can do with me, and you're authorized to do this. And then the actual communication starts, right? That's the third part, right? So now the client agent says, hey, here's a job I need you to do. And the remote agent might say, great, that's awesome, but I need some more information. And it asks for the information, the client agent responds to it. And then depending on how complex the task is, maybe the reservation task is just, hey, it gives you an intermediate update saying, I found 10 airlines or 10 flights that match your criteria. What do you want? And some of these are booking like last seats remaining or whatever, right? Since you some updates and asks you for some additional information, etc. And then the final response and the artifact is provided, right? So you need all 3 pieces in order for a full communication to happen between 2 AI agents. Okay. So then let's look at how these agents get deployed, right? So you can have a single agent deployment, right? So you could have just one agent sitting out there. Maybe it's just reading your emails and your calendar and summarizing your emails, setting up meetings for you. Maybe that's a single agent, simple use case, right? The more complex scenario is in enterprises, right? In bigger companies, you're going to have a multi-agent scenario. You'll have one master agent which delegates tasks to multiple things. Maybe it has to do customer service management, but then it has to check with the finance department to see if this customer is in good standing, right? Maybe it has to check with the billing department to say, is there anything outstanding, or do we have an active account? Maybe it has to check with the customer service side of it and say, okay, what language should I interact with this customer on, etc. Right? So there could be a very complex architecture of agents where there are master agents that control slave agents for all practical purposes, and something has to orchestrate that. You could also have peer-to-peer agents which are equivalent in functionality. So one example is distributed infrastructure management, right? So maybe you have to have some load balancing, and there is network error correction on like identical networks, whatever. But agents are peers, so when things happen here, maybe it has to keep a backup on the other one, right? So they talk to each other and trade information as equals. And then last but not the least, which is my favorite, is there's a human in the loop somewhere, right? Meaning you have an agent, you want it to do, say, a firewall risk assessment, or you want it to even say, generate your annual report, right? That's great, it does that, but that report is not going to go out to public without a human reviewing it first. That firewall change is not going to be actually written into the firewall without a human reviewing it first and making sure it's not going to cause an outage or conflicts with other things, right? So putting a human in the loop for high risk is another deployment scenario. So what does that mean? Let's now think about the attack surface, right? And I think I've already seeded your brain with some thought in terms of what's happening, what are the component parts, etc. So your attack surface traditional, right? Especially as a broadband provider, is first of all, it's your money, right? If you attended my prior webinars, you've probably seen this slide as well. It's your money, it's your infrastructure, your servers, your network, the fiber that you have, all of that. It's your data, whether it's your customer data or your enterprise data. And then it's your employees, right? So you can target your employees and maybe phish them and have them reveal information accidentally, etc. Or it can be a customers, right? Maybe an attacker can attack your customers and cause an outage, even though it's not really an outage. And then last but not the least, it's your reputation as well, right? So I think in one of my webinars, I talked about, hey, what if you had an AI agent that does nothing but sit and write bad reviews about you on all of the websites, right? What are you going to do? Are you going to go issue a cease and desist to a AI agent that's running on a server in Laos, right? That's not going to happen. So that's part of your attack surface as well. But now, in the context of today's webinar, you would have realized that that attack surface has actually expanded. There's another element to it, which is your AI. And there's two pieces to this. It's the LLMs that you use and the agentic AIs that you use, which also have LLMs inside them, right? So you have to think about this as part of your attack surface as well. And let me walk through some examples, etc., as to how these get compromised. So here are some headlines that have happened just in the last 2-3 months. One is about a year old. Last year, if you heard of the company Replit, they produced an AI agent which went and deleted an entire customer's database, right? And the Replit CEO had to apologize, right? Agent just went rogue. It just made its own decisions. As part of the thinking process, it got into a wrong set of logic, and then it decided it has to delete a customer's database. Huge hit. One that's making the rounds in the news right now is this developer who had an AI agent submit code to him. He reviewed the code and rejected it because it was not of the quality he expected. The AI agent went rogue and started posting bad things about him all over the internet. And he only found out because people were like, somebody's posting a bunch of stuff about you. And he found that it was actually the AI agent. There were a couple of other things that have happened. One is Amazon had an outage, and this one I put it in kind of like a dark because Amazon is not denying the cause, but the outage has happened. Initially, they said the outage happened last week because I think it was the last week or the week before because of an AI coding bot, right? An Amazon outage. But multiple studies are being done as well, right? MIT did a study, OpenAI. There's another research study on OpenAI as well, where AI is going rogue. These agents are going rogue, refusing to either shut down or engaging in actions that they were not originally expected to do. Well, but if you think about it, they are expected to do it, right? Because they were given a job and they were told to figure out, find any way to go do it, right? So that's where it's important to have these AI guardrails around it. But let me give you some more concrete examples from like 2024 and 2025, which will talk about how the protocols are being used and how the component parts of the AI agents are being used. So 2024, there's a prompt injection attack, right? Where somebody had set up an AI agent and linked it to their email inbox and their calendar, right? So it basically analyzes the email, summarizes it, etc. What an attacker did was he crafted an email to that person, but in the content of the email, it had hidden instructions, right? So escape characters and then instructions, and then for the agent. So what the agent ended up doing was it got programmed to send sensitive emails to an external email address. Now, if a human had just read that email, you would have seen the gibberish characters and the hidden commands. But because an AI agent read it first, it processed the instructions. Second attack, malicious MCP server. So this is what I talked about. Be careful who you get your MCP server from. So a threat actor published an MCP server mimicking an legitimate company's MCP server, right? And what it did was, now that every agent that connected to that MCP server, this malicious MCP server was able to manipulate them. Third is an attack where there was a very super targeted spear phishing attack. So personalized spear phishing attack, but at scale, right? Targeting everybody in a company, right? So this was and I think this is now available as ready-made kits. So an attacker basically uses an agentic AI. It goes and researches every employee of your company and finds out everything about them, not just their work life, but also their personal life, what apps they use, what devices they have at home, what websites they visit, what are their hobbies, what are their interests, where do they, what are the places they visit most often. It collects all this information and then sends like hyper-targeted spear phishing emails to employees of the company. Then fast forward to 2025. Remember I talked to you about the tiered architecture model of AI agents, where you have an orchestrator agent and you have subordinate agents. Now, what happened in this is that an agent was manipulated through a tool, a subordinate agent, to elevate its permissions and get even more elevated permissions from the orchestrator agent. So now it was able to enforce actions on that corporate environment that are way beyond its original scope, right? Another example, an AI agent that was given broad access. So you have to be careful about the extent of access you give it. So that agent is compromised, and it started to autonomously map the entire network of that entity, of that company, identify where the crown jewels are, meaning the high value targets. Hey, here's the customer database, here's the employee database, here's the rack for the servers that can shut off the whole network. Identify all of those and then plant ransomware specifically on those. And all this automatically done by an AI agent. So what's happening, right? So if you've attended my previous sessions, you've recognized this, but if you haven't, this is the 20-year-old framework that Lockheed Martin put out called the cyber kill chain, right? And 7 steps that basically outline how a cyber attack unfolds. With AI, without AI, it doesn't matter, right? It's just a framework for how an attack unfolds. So there are 7 steps, and what's happening is that the time required between these steps is getting compressed. Sometimes it used to be days to do reconnaissance. Now it's minutes. Sometimes it used to be days to traverse a network, months even, but it's like it could be minutes or seconds now. And it's being done autonomously by agents as well. So when you're threat hunting and you're chasing somebody around a network, you're not chasing somebody at human speed, you're chasing somebody at AI speed, right? So there's compression of the cyber kill chain. And keep this in mind, because I'm going to come back to a different flavor of this in a couple of slides. So how can we start thinking about solutions to this problem? Well, the good news is it's not just us, but a whole bunch of people, the whole world is thinking about it, and there's now a ton of frameworks and guidelines. In fact, there's an alphabet soup of frameworks and guidelines happening, and it's moving faster than anything I've seen before in my entire life. Just think about when you start to hear about AI agents, and there's already all of these frameworks. And by the way, many of these are still in draft, and even the ones that are V1 are still hyper fast evolving. So you're getting V2s and V3s like much quicker as well. So these are moving really, really fast. You have to keep a constant eye on it. And I'm going to give you some pointers on what to keep in mind in the coming slides. So first, let's step out of the agentic AI world and just into the AI world, right? So remember that cyber threat kill chain I just showed you. There is a AI kill chain now. So MITRE has put out a 14-step kill chain specific to LLMs and AI systems. Now, this is a really cool kill chain because if you go to this page, and I have the link to it in the slide deck, which I will share, each of the blue text that you see on the slide are all links. So you can literally click on the specific type of attack. And in many cases, it tells you what, not just what the attack is, but it also tells you how to protect yourself against it or how to find signs of it, right? So there's like really valuable information on each of these. So highly, highly, highly recommend. If you don't do this yourself, at least have somebody on your team start to get familiar with the MITRE Atlas matrix. Next look at NIST, right? So where is NIST in this? Well, NIST is in this a lot, it turns out. So there are 3 frameworks that are currently in play, right? The NIST RMF, so first of all, this is a voluntary framework. The cool thing is that it integrates with the existing NIST CSF. So it's kind of very complementary to it. And it's for anybody who's deploying and using AI, right? But again, it's a voluntary framework. That's all it is. Then there is NIST AI 600-1, which is specific to Gen AI. So let me be very clear what I mean by there's AI and then there's generative AI. Generative AI is where you're using AI to produce all new, never done before outputs, right? Say you're in video production, or you're creating all new algorithms, or you're creating all new content. For those kind of scenarios, it identifies the risks for generative content. Importantly, it does address like AI agent unpredictability as part of it, right? By the way, I believe only RMF and 601 are in V1, but again, these are evolving, like I said, constantly. And then last is NIST is IR 8596. Again, rapidly evolving, just published in 2025. This is still in draft. It's not finalized, but it maps your NIST CSF 2.0 controls to AI-specific threats, right? So the way I think about these frameworks, these are all going to evolve over time and kind of meld and merge is my expectation. But as it stands to me, there are lots of complementary pieces to this. They're not competing, but rather complementary. Then let's look at what other frameworks are there outside of NIST, right? Then this is one I love, OWASP. OWASP puts out a bunch of stuff. Please bookmark the OWASP website, especially the OWASP top 10 for AI LLMs, right? What it is, it gives you a bunch of top 10 threat vectors, and it gives you a prioritization of the threat vectors, which is why it's super crucial. They also have an AI agentic security guide. This is quite a read, but you should have somebody on your team have a look at this and start to get familiar with it. But importantly, it addresses multi-agent situations and MCP and tool security situations. So that's very, very, very crucial. Then there's MITRE Atlas, which I just talked about. Now, MITRE Atlas is not for specifically for agentic AI. It's for the LLM part of the agentic AI, right? So let's be very clear about what it is, but it's a crucial part of the whole equation. And then last but not the least, if you're looking to get certified, etc., there's this ISO standard that's come up that you can use. So total alphabet soup, like I said, I'm still struggling to get my head around all the pieces of the puzzle. So what I did was I just created a table, and I'll share this with you all as well, which basically says, here's the framework, who's it for, and what it addresses. And as I understand it for rural broadband right now, I think the ones I would keep my eyes on are the NIST ones, and then the OWASP, and then a little bit of and the MITRE. Unless you're going for certifications or you're starting to do cloud-based agentic AI, I wouldn't worry about the CSA or the COSAs just yet. The COSAs is more for like critical infrastructure. If you are doing, it's for companies that are doing federal work or defense work, etc. But if you are not doing any of that, I would just keep your attention to the NIST, OWASP, and MITRE. Okay, so how do you defend against this, right? So some things don't change on this planet ever, right? Old cybersecurity, new cybersecurity, or just security for your home, etc. So one is the criminal needs three things. The criminal needs motive, they need skills, they need resources. There is absolutely nothing you can do about motive unless you've gone and angered somebody extensively. But outside of that, there's nothing you can do about anything about motive, but you can affect the skills and the resources. Second is that, and again, you've all probably seen this slide from my past presentations. I've been using this slide for 20 years. It's a really cocky thing to say, but I continue to use it because it has relevance every time I use it, right? And with agentic AI, this is even more relevant because you could have an agentic AI agent in your enterprise or the one that you're using that's gone rogue, but it may have gone rogue in a very subtle fashion. It might be feeding you back outputs that are subtly modified, right? So think about it from the point of view of cybersecurity. You want indicators of compromise, right? So you want to see a breach, you want to see malware, you want to see something in your logs. This may never have that, right? It may be in the poisoned output that you're getting, and it looks good, it feels good, and maybe even you're using it, and then the outcomes are like much later, right? So that's why I think this still has relevance because this could be a hidden threat. Second is that cyber defense is a risk reduction. There is no concrete solution, right? You're trying to reduce your risk constantly. And how are we trying to do that? You're trying to do that by increasing the cost of attack, right? And that's your one objective. Whatever the tools are, whatever your infrastructure is, it should be harder tomorrow to attack you. It should be more expensive tomorrow to attack you than it was today, right? That's the whole thought process. And you're going to do that with a combination of three things: tools, people, and process. And I'm going to walk through exactly some of those. And then last realization here is that AI feeds on data, guys. I mean, it gets stronger and stronger with the data you feed it, right? So you have to reduce your data risk or your privacy risk in order to improve your security. Because if you start revealing everything here on the left side, it becomes so much more easier for the AI or a human to use AI to deliver any and all of these kinds of threats on the right side. So what can you do right now, right? So how do you have to think about this? So you have these frameworks, you have the tools, you have all of that. So immediately what you can do in the first 30 days is you can do, this is free. This is going to be completely free the first 30 days. Just do an inventory. What LLMs are you using? What agentic tools are you using? Just write it down in pencil and paper, right? Maybe there's some shadow AI that some employees are using, and you have to send out a questionnaire and just ask them that, right? Put together an acceptable use policy, right? I'm sure all of you have an acceptable use policy for various things already. At least modify that and put together one for agentic AI. And then identify your highest risk touch points, right? Where are the crown jewels, billing, network, customer data, whatever it is, where are those on your network? And are LLMs and or agentic AI connecting to it, right? So this is easy to do in the first 30 days. And then last but not the least, CISA alerts. Again, free. So no arguments here. Everybody can do this, pencil and paper with a little bit of talking, and it's all free. Then longer term is you need to start looking at running controls, right? So what if some employee accidentally uploads a spreadsheet or a PDF to an AI or an agentic AI, right? So how do you prevent that or at least get visibility into that, right? So what about running, what if something like that happens? Run a tabletop exercise, or maybe even a prompt injection for the AI that you're using and the agentic AI that you're using. Use some prompt injection tabletop tests and seek what kind of outputs come out, what kind of reliability you can have for these kinds of agents. And then map your tools to the OWASP top 10 that I just talked about and identify the gaps. And talk to your vendors, right? Vendors are all using AI right now. Maybe it's not in the product they give you, but maybe it's in their customer service handling. Maybe it's in their billing. Understand where they are in their AI use and how, whether directly or indirectly, it affects you. 90 to 80 days. This is where I would say start going into the framework, start looking at the various frameworks, and start logging it. If you have a SIM, have the AI agents activity log into a SIM. If you don't have a SIM, identify some other way in which you can start to look at the logging activity and have an incident response plan for it. A lot of training, of course, on deep fakes, etc. And then strategic over 6 to 12 months, start doing your certifications, have an actual risk committee. And actually, I put this in the 6 to 12 months, but there are two things here that I think we should, two things here that you can potentially do in the first 30 days as well. One is to set up an AI risk committee in your company. Maybe it's just you, or maybe it's 2 to 3 people one from finance, one from marketing, one from whatever, right? Have a 3 people team, 2 people team, something where they are responsible for the extent of AI risk, and they are asking everybody questions and capturing information, etc., and also being reported to on the solutions that you find. The second thing that I think you can do right away is what we are calling the Kavlan Agentic AI framework. It's a maturity matrix. What is this? So we came up with our own maturity matrix to kind of be a guideline through the process. And not only that, we made it an interactive tool and made it a Claude artifact, and we actually published it. So let me actually show you what this is. It's super easy to use. It's free. It's anonymous. Unless you submit your email to me, I don't even know you're here, right? But it's interactive. So based on various dimensions, which I'll just go over real quick before I jump back into this, is 5 dimensions, which are governance. First of all, visibility, and then identity, who has access to what, your resilience, etc., and levels of maturity for each. We created this with this maturity tool. So you can essentially go in there and you can say, I am at the governance and policy. I am at a formal policy exists, and then it interactively scores you. So now you can complete the whole evaluation, and then you can take a printout, etc. If you want a personalized version of this, you want a customized version of this, let us know. We can work with you. Or better yet, is if you want this integrated with your AI control so that there's some level of automation, we can do that as well. But right now, this tool is just out there for free, completely anonymous. Unless you come in here and fill your email and send it to me, I won't even know you're here, right? So we're not going to share this with anybody either. This doesn't even get submitted back to us. So it's just for you to use and print, etc. So then, so that's it. So on resources, I talked about MITRE Atlas, the OWASP Privacy and Security Guide. A couple that I want to point out here that I didn't talk about in the presentation is these are super deep technical. Google has something called an agent development kit. So I highly recommend that you go check it out. The link is here. And on that page, there's actually a link to a YouTube video, 15-minute YouTube video that just manually walks you through how to set up your own agentic AI on the Google platform. It's super simple to do. It's a really good walkthrough. Yeah, try it out, right? Get a feel for things yourself by trying it out. And pro tip, when you're done, make sure you power off that AI agent so that you're not running up a bill on Google, right? So that's crucial. All the other links, it's all out there. And I'm also giving you a link to the Agentic AI Security Maturity Model, which is on our website. So please feel free to use it. So with us, if you want to talk to us about your agentic AI security needs, or you want to talk about AI and cybersecurity in general, or learn about what else Nandi does, etc., how we use AI in our products, happy to talk about any and all of that separately. And with that, I will open this up for Q&A since we have only about 6 minutes left. Any questions, you can just put it into chat, or you can just open up the microphone and ask. Was this useful, gentlemen? Was there information here that is
yes,
actionable?
I thought it was useful, and there was information that I haven't heard before, and I enjoyed it. And I want to see the slide deck again whenever.
Oh, I'm going to email it to you. I'm going to email it to you with all the links in here as well.
Yeah, thank you.
And I'll send you the survey link too, so you can use it within your company as well. Oh, don't ask them to do the survey there. The responses will come to me. You can just copy the questions and use it within your company, so you can get a sense of what's happening inside your company.
So I don't have any questions really about the security. I have a small office and I use AI tools a lot. But agentic AI is something that we have not really implemented yet. And in Louisiana, there's not a lot of companies that have implemented it. So I think if I can learn how, there's a business opportunity here in this area, and then in turn, when customers start to use agentic AI, that opens up a more of where you could come in for the security aspect of it.
Yeah, totally happy to help on both fronts, by the way.
Okay.
And I would one thing I would want is based on all the conversations that I'm having, one of the things I'm finding out is that people are not realizing that they are already using agentic AI. In many cases, they're just seeing it as like a chatbot or like a customer service.
Yep.
They're not realizing that it's agentic behind it. It's kind of hidden. So it might already be there. We just don't know about it.
Yeah.
So identifying the use cases is critical.
So would you say like Claude Code? So I use Claude Code probably almost every day,
Yeah,
and you're using Claude Code. So it has its own little agents who go out and run tasks on its behalf, right?
exactly. Yeah, in that case, your Cloud Code, for the most part, I think it just works with the Cloud AI. So the LLM behind it is kind of limited. But yes, it's basically an agent, and you're you are also revealing to it your core IP, right? Whatever the code it is that you're generating, if any part of it you intend to have it as proprietary,
Yes.
then you want to be super careful about how you use it, right? Um, what I recommend is hybrid environments, right? So if you're writing your own proprietary algorithms like we are, right? Um, this proprietary stuff we're just doing on like the normal old school development environments, right? But there are non-proprietary. Hey, we have to put all these pieces together of the puzzle together. All that we can happily do with like AI-based the things that are just grunt work, right? So AI-based development tools, we can do it that way.
Okay, thank you.
Um, the other thing I would also recommend, if you have to use AI for proprietary stuff, is disperse your risk. So you think about your proprietary algorithm problem, break it up into like 4 parts, 5 parts, 6 parts, whatever, and then give different AI pieces different parts of the puzzle, and you do the assembling. So no one piece can figure out the entirety of it, and yeah, and don't put it on an open GitHub, right?
Yeah.
It's a closed GitHub.
Just, and I'll be quick because I know this is about to end, but that just brings, so I'm trying to develop something right now using a lot of Claude Code that I want to have copyrighted. Do you think that's already like hosed up because I've already have been using Claude Code, or?
Um, I don't think so. You might still have a channel. Like with Gemini, I have a setting. In our company, we pay for Gemini.
Yeah.
There is a setting in it where I can turn off Gemini to be trained on anything that we do.
Yes, I think I turned that off.
Yeah. So if you have turned it off, I think you're protected.
Okay.
Um, uh, you may still want to review the terms of service just to be sure, but at the minimum, at least you have a claim if they start using it. Now, here's the hard part, right? If the AI takes your code and starts to learn about it, there's no the proving that for someone like us is going to be almost impossible,
All right. Yeah, thank
right?
you.
When how do you take this to court, right?
Right.
And do you and I have the money to take them to court?
Right.
that's
The
so
answer
there's
is no for me.
exactly. It's no for all of us combined. Let's just
Yeah.
say it that way.
I appreciate it.
No problem. Other Brian, Nathan, any questions? Okay, so we are at the top of the hour. Uh, thank you all for attending. Hopefully this is useful. I will follow up right after this with the deck and the links. All I ask is if you do use the content from the deck, please do give attribution. but otherwise, feel free to use it any way you want. Thank you, gentlemen.
Yeah,
Thanks
thank
for
you.
attending.
Yep.
Bye-bye.